Here is the solution for day 2, problem 1. Determine the x-intercepts of the graph of this expression right here. This is a hyperbola because of the minus sign. When we graph the hyperbola, it will cross the x-axis at some place. We can figure it out by actually graphing, or we could try to figure out the answer without taking the time to graph. Let's put some thought into what the graph would look like. When the x squared is the first term before the subtraction, that's the sideways opening hyperbolas. Think about graphing that shape on an x and y axis. Remember how you go left a little bit and right a little bit, and you draw in the box shape? And then you draw the diagonals of the box shape? But what about when you actually get to the step about drawing the branches? They touch at the sides of that box, and they go like this, and the other side goes like this. Those two spots are the x-intercepts. Well, what value did we use to go to the left and to go to the right to make the box? That's the value of a. So this question is really asking us about the value of a. Using a square root, a is 6. And what you do with a is you go to the left from the origin to get this x-intercept, and you go to the right from the origin to get this x-intercept. So when you go left, the x-intercept is -6, 0. When you go to the right from the center, the x-intercept would be 6, 0. Those are the coordinates of those two dots on the hyperbola. Day 2, problem 2. Determine the foci of this hyperbola. Well, what are foci? That's the plural of the word focus, and it refers to the points that are inside the parabola branches. To help us understand the question, we could make a graph. A is 3, and B is 4. So if you were to graph the hyperbola, you would make a grid, and you would go 3 units to the left, and 3 units to the right, 4 units up, and 4 units down. And draw a box through those spots. Next, you would draw the diagonals of the box. Then you would fit in the parabola branches, as shown in red ink. Where are the foci points? They are inside of the parabola curve. So the focus of the left section is a dot located approximately right there. The focus of the right section would be a dot located about right there. How do we find those dots? This is where we need to know the value of C. The distance between that spot and the focus dot is C. And similarly on the left side, the distance between this dot and that focus dot is C. What was the distance between the center and this dot? That was the value of A. And similarly on the left side, the distance from the center over to this dot was A. So think about how you can get the coordinates of this focus point right here. It would be A plus C, 0. What would be the coordinates of this focus point over here? It would be -A minus C, 0. Because from the center you go left A units and an extra C units. So we need to figure out C. And we have the formula for C up above. Using the Pythagorean theorem, C is equal to the square root of A squared plus B squared. So we have the square root of 9 plus 16. That's the square root of 25, and that equals 5. Now that we know A and C, we can get our answers. The focus point on the right has the coordinates 8, 0. And the focus point on the left has the coordinates -8, 0. Those two ordered pairs are the foci.